Good day, students, and welcome to the complex practice test for trigonometry. You recall that the document that I'm going over right now is accessible on the www.ect.org website. Okay? All right, let's go ahead and take a look at question number 1. It says, in the right triangle shown below, the length of AB is 8 units, angle A measures 60 degrees, sine 60 is approximately 8.866, cosine 60 is 0.5, and tan 60 is 1.73. Approximately how many units long is segment BC to the nearest hundredth of a unit? Okay, so this is a right triangle trigonometry problem. How do we know that? Well, we know that because it involves two sides and an angle, all right? All right, so anytime we want to use right triangle trigonometry, it involves problems where we have angle, it could be angle side side, or let's say side angle side. It could be side side angle. It could be angle side side. Any of these configurations involves the use of right triangle trig. Okay. So what do I mean by right triangle trig? Well, I'm talking about SOHCAHTOA. SOHCAHTOA. Okay. So this basically means sine is opposite of a hypotenuse. Cosine is adjacent of a hypotenuse times opposite of adjacent. Okay. So to solve this problem, we need to make use of either sine, cosine, or tangent. Okay. You notice we're given sine, cosine, and tangent in the problem. Okay. So the question is, which one do we use to solve this problem? Well, we're going to label the triangle. We indicate what we know what we need for the SS, and then we're going to determine the right ratio. All right. So this is the angle that we're given. I'm going to call this the reference angle. The side opposite the reference angle is segment BC. This is the side we're looking for. Let's call it X. All right. So this side that's opposite the reference angle is known as your opposite. Okay. So that's the O in SOHCAHTOA. The O here and the O there. The side opposite the 90 degrees is the longest side and is always known as the hypotenuse. All right. So that's the H in SOHCAHTOA. And this side right here is the adjacent, the other side. Okay. If you look at this problem, I don't need the adjacent and I don't know it, so I just scrap it. It doesn't play any role here. I just need O and H. So I'll ask myself the question, which trig ratio, sine, cosine, and tangent, has O and H? You can clearly see it's sine, right? So what does this mean? It means sine, so means sine, theta equals opposite over hypotenuse. Okay, so it's good to remember SOHCAHTOA for your exam. Alright, so let's go ahead and apply to this problem. So sine of theta is the reference angle, 60 degrees, equals the opposite, which is x, over the hypotenuse, which is 8. Okay, remember we're looking for segment BC, which is x. So to get x by itself, we're going to multiply both sides by 8. So multiply by 8 and multiply by 8. And we're going to have x equals 8 sine 60. Okay, so we're allowed to use a calculator in this exam. So let's go ahead and input this expression in our calculator. So I already have it entered here. Let me do it again so you can see. Alright, so I'm going to enter 8 times sine 60. Now, we know that our angular measures are in degrees, so let me set my mode to degrees real quick so that I don't get the wrong answer. So it's in radian. So if you have a complicated sign of your calculator like this, make sure you're in the right angular measure system. So it says degree here. Enter. 4/3, approximate answer is 6.93 to the 10th place. Okay, so x is, let me write down the whole thing first. X is 6.9282. So x is approximately 6.9282. Well, the problem asks us to round it to the nearest hundredth. Okay, so we know that this is a tenth, This is 100, so we're rounding it to this place right here. So since this is bigger than 4, this is 5 or greater, we're going to round up. So x is going to be approximately 6.93. Okay, so segment BC, the length of segment BC is going to be approximately 6.93. So our answer is option letter D. All right. Okay, let's move along. Question 2, it says if sine theta is 12 over 13 and cosine alpha is a 5 over 13, what is tan alpha? So this involves knowledge of your trig ratios. You need to know the quotient property, quotient identities, which basically says that tan of any angle, let's say theta, is sine theta divided by cosine theta. Okay? So tan is a quotient of sine and cosine. All right, so let's apply this idea to this problem. So this tells me that tan alpha is going to be what? It's simply going to be sine alpha over cosine alpha. Okay? So what is the value of sine alpha? Sine alpha is 12 over 13, so we can put that into the numerator. Divided by the denominator is cosine alpha, which is 5 over 13. Okay? Now, how do we do this? Well, let me write this ratio horizontally. So it's 12 over 13 divided by 5 over 13. So how do you divide fractions? What you do is you multiply the fraction on the left by the reciprocal of the fraction on the right. You drop, change, flip, right? So you drop this fraction, 12 over 13, change division to times, and you reciprocate this into 13 over 5. Remember, dividing is the same thing as multiplying by the reciprocal. Okay, so I just reciprocated the denominator, which is this fraction, it became 13 over 15. Now we're going to multiply, okay? So I can cross-reduce. Before doing that, 13 goes here 1, 13 goes here 1, and divide out. When I multiply, I'm going to have 12 over 13, okay? I mean 12 over 5. That's going to be my answer, 12 over 5. So there you have it. All right, so that's option letter C. Okay, let's take a look at number 3. It says if theta is, or if x is between 0 and 90 and sine of x is 1/2, then what is cosine of x? So we know that in the first quadrant, all 6 trig ratios are positive. So if I set up my coordinate system like this, this is 0 degrees, and this is 90 degrees. I know that if x is in this quadrant, quadrant 1, all my trig ratios are positive. So sine, cosine, tangent, and the reciprocals are cosecant, secant, and cotangent. They're all positive in this quadrant. Okay? If we go here, we have S, and then we have T, and we have C here. Okay, so this means sine and cosecant are positive. And then this T means that tan and its reciprocal cotangent are positive. And this one means that cosine and its reciprocal secant are positive. Okay? But since we're in quadrant 1, between 0 and 90 degrees, we don't need to bother about negativity here because we know that everything is going to be positive. Okay? So what is cosine x? Now there are 2 ways of doing this problem. Let me show you the first way. The first one involves the knowledge of the identity, the Pythagorean identity sine squared x plus cosine squared x equals 1. Okay? If you know this identity, then you're in good shape. Alright, so let's use this formula first. Let's call this method 1. And then I'll show you another method. It also requires the knowledge of something else. Okay? So to solve this, I'm going to substitute sine with 1/2. Okay? So I'm going to have 1/2 squared for the sine plus cosine squared x equals 1. The goal is to get cosine by itself because that's what we're looking for. So let's go ahead and see what we can do here. Let's simplify this a little bit. We have 1/4 plus cosine squared x equals 1. Alright, so to get cosine by itself, I need to move this 1/4 over and then just take the square root. Okay? Alright, let's go ahead and do it. Let's subtract 1/4 from both sides, and then that's going to give us cosine square x equals, what is 1 minus 1/4? The 1 minus a quarter is 3/4, right? Or we can make it 1/1 multiplied by 4, top and bottom. So this becomes 4/4. So 4/4 minus 1/4 is 3/4. Okay? Alright, now to get rid of this square, I'm going to take the square root of both sides. The left side, the top, and the bottom. Okay? So this now becomes cosine x equals plus or minus the square root of 3 over the square root of 4, which is 2. Okay? Since we are between 0 and 90 degrees, we know that cosine is positive. So we're going to drop the negativity. Okay? So we're going to have cosine x equals √3/2. So the answer is option letter D. Alright? Okay. Now method 2 involves knowledge of your the value of your trig ratios for the common angles. Okay. Method 2, the common angles are 0, 30, 45, 60, and 90. Okay. If you know the sine, cosine, tangent of these angles, that is very good and extremely helpful. It can help you do a lot in your brain. Okay. Okay. So in this if you have knowledge of this, you will know that sine of 30 degrees is equal to cosine of 60 degrees, and that's equal to 1/2. You also know that sine of 45 degrees is equal to cosine of 45 degrees, and that's equal to √2/2. And you also know that sine of 60 degrees is equal to cosine of 30 degrees, and is equal to √3/2. So knowing that your sine, if you know this fact right here, that's really helpful, and then the tan has its own function too. Alright, so let's assume that we have this memorized. Okay, so how do I use it to solve this problem? Well, I'm told in the original problem that sine x equals 1/2. What does this mean? It tells me that sine of something is equal to 1/2. So I know from here that sine of 30 degrees at something has to be 30, okay? But how do we show it mathematically? What we do is we take the inverse of both sides. So I'm going to take the inverse of sine on the left side. And on the right side, we take the inverse sine of 1/2. Okay, this is a formal mathematical way of showing how you come up with 30 degrees. So sine and its inverse cancel out on the left side, so you have x equals the inverse sine of 1/2. So what is the inverse sine of 1/2? It's basically asking what do you take the sine of to get 1/2? 30 degrees, so x equals 30 degrees. Okay? But the question asks us to find cosine x. So now I know that my x is 30, all I'll just do is I'll take cosine x to be cosine of 30 degrees. And we have already established it here from memory that cosine 30 degrees is √3/2. Alright, so cosine 30 degrees is simply √3/2. Alright, so there you go. So whichever method you want to use, it requires some degree of memorization. Either you know the trig ratios for your common angles, or you know your Pythagorean identities, okay? So whichever way you do it, the answer is option letter B. Alright, let's move on to question 4. It says, from a hot air balloon, the angle between a radio antenna straight below and the base of the library downtown is 57 degrees, as shown below. If the distance between the radio antenna and the library is 1.3 meters, how many miles high is the balloon? Okay, so let me put the x here. So this is if you notice, this is a angle side problem, so we have to use right triangle trig. If you have two sides at an angle, you always have to use a right triangle trig. Okay, so what is right triangle trig? So, all right. So the question is, which is applicable to this problem? Sine, cosine, or tangent? Okay, so we know this is a given angle. I'm going to call it the reference angle. The side opposite the reference angle is known as your opposite. That's the O in cataract, the O here and the O there. So it's either going to be either sine or cos, sine or tan. It can't be cosine because cosine doesn't have opposite in it. Okay. All right, and then this side right here, well, this side, the side opposite 90 degrees is your hypotenuse, and the other side is your adjacent. In this problem, I don't know my hypotenuse, and I don't need it, so let's scratch it. It doesn't play a role. But I need my adjacent because that's what the question asks for. So we have O and A. Which trig ratio has O and A? Sine or tan? It's clearly tan, okay? So TOA basically means the tan of the reference angle theta equals opposite over adjacent, okay? So let's apply it to this problem. Tan of theta is 57, equals opposite, which is 1.3, over the adjacent, which is x. X is what we're looking for, okay? It's how high the balloon is. So how do we get x by itself? Well, we have x downstairs, so we need to bring it upstairs. What I'm going to do is multiply both sides by x to bring it upstairs first, make it a numerator, then I'll focus on isolating it, all right? So multiply both sides by x. On the right side, the x's divide out. And on the left side, we have x tan 57 equals 1.3. And then to finish this up, we just divide both sides by tan 57 on the left and on the right. And then the final answer, x, is going to be 1.3 over tan 57. Okay? We don't need to go any further because it's consistent with the option we have here. So the final answer is option letter C. Alright, so there you have it. Okay, let's move along to question number 5. It says, what is the simplest positive value for x when y equals sine 2x reaches its maximum? So you just need to remember what the maximum of a sine curve is. The maximum of a sine curve is given by the value of a, okay? So what's the number in front here? So we have y equals sine 2x. The value of a is the max or min, okay? So there's no number here, so there's a 1, okay? So this value right here is your a, okay? So 1 will be your max, and the opposite of that, -1, will be your min. Okay, so that's basically what the maximum is. All right, so it says what value of x will allow this function, what will the value of x be when this function is at its maximum? So what we're going to do is we're going to set up an equation and solve it. All right, so the question we're going to ask ourselves is when is sine 2x equals 1? That's the question. When is sine 2x equals 1? To make this equation easy to solve, it's good to remember what your sine curve looks like. Okay, so I'm going to sketch a sine curve here. Remember, your sine curve basically looks like an S, right? So you can break it into 4 quadrants: 1, 2, 3, 4. The sine always starts from the center, goes to the max. So it goes something like this. Goes to the max right there, back to the center, and then goes to the min, and then right back to the center, okay? So this is 1, and this is -1. And this is pi, this is 2 pi, and this right here is pi over 2. Okay? It's good to remember this graph, 3 pi over 2. All right, so when is sine equal 1? Sine is at its maximum first at pi over 2. Okay, and then it happens again when you add 2 pi to that, which is basically 5 pi over 2. But the question says, what is the smallest positive? So we're looking for the first time that this sign attains the value of 1, which is pi over 2. Okay, so we keep that in mind. All right, so what we're going to do in this equation, I want to get rid of sine, so I take the inverse sine of both sides. So I take the inverse sine of sine 2x equals the inverse sine of 1. Okay? On the left side, the inverse sine and the sine cancel out. So we're going to have 2x equals the inverse sine of 1. So this expression is asking you for what angular value does sine equal 1? We already established it here. When sine is pi over 2 or 2 pi more, so pi over 2 and then pi over 2 plus 2 pi plus, and then the next one another pi over 2 plus 2 pi, plus 4 pi, and the pattern keeps going on. Basically, we have a general formula for that. You already know what it is. The solution that satisfies this 4 pi is basically pi over 2 plus 2 pi n, okay? But we're looking for the smallest one, so this is the one we take. So the inverse sine of 1, even though all these results satisfy, the smallest one is what we need, so pi over 2 is what we're going to take, okay? So we have 2x equals pi over 2. So let's get x by itself. How do we do that? Since we have a fraction here, I don't want to divide by 2. I'm going to make a mess. So how about I multiply both sides by 1/2? Remember, dividing by 2 is the same thing as multiplying by its reciprocal, which is 1/2. So I multiply both sides by 1/2 because we have a fraction on the right. All right, so this side, these two is divided out. So you're going to have x equals multiplying across pi over 4. Okay? So your answer to this question is option letter A. All right, moving right along. Question 6, it says, one of the graph below is that of y equals a sine theta between 0 and 6.28 pi, where a is a constant. Which one? So we need to remember what the sine curve looks like. Remember I told you earlier that the sine is like an S, okay? The parent sine curve is of this form: y equals 1 times sine theta, okay? So it's like an S, and it goes like that. So this is one complete period, okay, of a sine curve. Now, if there's a shift up or down, then that changes things, okay? So since this looks very much like the standard parent sine curve, this A basically tells you how high or how low you go. So let's look at the options and see if we can take out anything. This right here is a cosine curve. The cosine curve is like a cup, okay? Let me sketch that for you. When you're looking at the parent cosine curve, it looks like a cup, okay? It's something like this. This is one complete cycle for a cosine curve, something like this, okay? So this is y equals cosine, 1 times cosine x, cosine theta, and this right here is the sine, all right? Okay, so which one can we take out? This clearly is a cosine, so that's no good. This is the reverse, the opposite of cosine, okay? So we'll take that out. Now it's either A, B, or C, but there's a problem here. This is shifted 1, 2, 3, and it's up. So this one is basically y equals a sine theta plus 3. This doesn't have any shifts up or down. So this cannot be the answer because it's shifted because of this plus 3. This doesn't have a plus 3, so B cannot be the answer. So it's either C or A because they're both S's. It would start from the center and it go up and down, all right? So, so to help us figure this out, we just need to figure out what the period is, okay? The thing that will just tell us the correct answer is going to be the period, all right? So, for this graph, this is one complete S. Right here, one complete S covers a span of 2 units. So the period here is 2. And the period here is let's say 6.2. So the period here is 6.2. Okay? So which one is the correct answer? What is the period of this graph right here? You know that 6.2 is close to a number that we know, right? It's like 2 times 3.14. You know what 3.14 is? It's pi, right? So this is basically like 2 pi. That's the period of this graph. The period of this graph is 2 pi, which is similar, close to 6.28. And the period of this graph is just 2. So the question is, what is the period of the original question? Let's see, what's the period of the original question? So that's what we're going to try and determine right now, okay? All right, so we're going to go ahead and look for the period. So to find the period, all you just have to do is we have to do the calculation. Period is basically 2 pi over b, okay? So what is b in this problem? Well, let's write it down. So y equals a sine theta. Now, what number is in front of theta right here? There's no number there, so we can put in a 1. All right, so guess what? The coefficient of the angle is always b. Okay, so this is a, and this one right here is b. All right, so what's the period of the original problem? If it's 2, then this is the answer. If it's 2 pi, then this is the answer, okay? So let's compute the period. The period is basically 2 pi over b, and as we established, b is 1, so it's 2 pi over 1, which is just 2 pi. And 2 pi is around approximately 6.28, which is 2 times 3.14. And you can see that that matches option A, because this period is like 2 pi or 3.14, okay? And remember, this is wrong because this has a plus 3 in it, okay? It's shifted 3 and it's up, and the original problem doesn't have a plus 3. That's why we eliminated this, okay? And this fails because the period is 2. We need a period of 2 pi, which is approximately 6.28, all right? So there you have it. Okay, now let's take a look at the last question, question 7. It says in the right triangle below, the length of AB is 13 units and the length of CB is 12 units. What is the tangent of angle A? Okay, so the tangent, how do we figure out the ratio of sides that gives us a tangent? To do that, we just write our special right triangle tree formula, SOHCAHTOA. We are dealing with tangent here, so the one of interest to us is TOA. Okay, so TOA means the tan of the angle equals opposite over adjacent. So all I just need is to determine my opposite and my adjacent here, and write the ratio, and that will be the answer. So I need a reference angle. What is my reference angle? We're taking the tangent of angle A. Okay, so before you use SOHCAHTOA, you must identify your reference angle, or else you're driving blind, and you don't want to do that. Okay, so first thing I want to do is identify a reference angle. That gives us orientation, okay? So now you can clearly see, since this is a reference angle, that this side opposite the reference angle is my opposite, or my O, okay? So this is opposite. This side right here is my hypotenuse. Why is it my hypotenuse? Because it is the side opposite the 90-degree angle, which is the longest side of the triangle, okay? It's always called the hypotenuse. And then the last side is the adjacent, all right? Okay, so SOHCAHTOA, for tan, we need opposite, which is 12 over adjacent. Oh, adjacent is missing. So what is this? If you remember your Pythagorean triple, you will know that this is automatically 5, because 5, 12, and 13 form a Pythagorean triple. Okay, so this adjacent is 5. All right? Okay, now let's assume that we don't know our Pythagorean triple. So how on earth do we find out what this is? All right, I'm going to have to use the Pythagorean theorem. All right, so anytime you want to find out if you have an SSS problem, side, you have two sides, you want to find the last side, you have to use a squared plus b squared equals c squared. Okay, so that's what we need to use here. So this is the hypotenuse, I'm going to call this c. This is my opposite, I'm going to call this A, and this is B, okay? So the legs, the opposite and adjacent can be called A or B or B or A, it doesn't really matter. But the hypotenuse is always C. There's no flexibility with that. All right, so A squared plus B squared equals C squared. A is 12, so 12 squared plus B squared equals 13 squared, okay? I want to find B, which is my adjacent, so I can plug it in here and know what tan of angle A is, okay? So let's solve this for B. Remember, it should be 5, okay? So 12 squared is 144, plus B squared equals 169. Subtract 144 from both sides. And then you're going to have B squared equals, if you subtract these two, you get 25. Take the square root of both sides. B equals 5. Okay, like we guessed earlier, B is 5. Perfect. So B is 5. Now we have our adjacent or our opposite. So tan of angle A is the opposite of our adjacent, as indicated here. The opposite is 12. The adjacent is 5. So the correct answer to number 7 is 12 over 5, which is option letter A. Alright? So there you have it. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel just by clicking up here so you can get updates to other cool math clips such as this. If you like this video, please feel free to click like down here. And please post a comment and tell me what you think about this video. I really appreciate it. More videos coming from mathgotserved.com. Thanks again and have a wonderful day.